we'll begin with some introductions to get things started as people trickle in still. So thank you everyone for attending our second Green Bagger series this year. We have a great presentation for you all. I'll first introduce kind of the Canadian Society of Agronomy and what we are. I'm Alexa Peterson, and I am the current student representative on the Canadian Society of Agronomy. The Canadian Society of Agronomy is a great organization that connects researchers and agriculture specialists across our country, so we can share great research like this and get involved. If you're not a member, I would encourage you to become a member because it comes with some great benefits, including access to journals, discounts on the Canadian Journal of Plant Science, awards for graduate students. You're able to join and present at series like these and share your research, recognition of awards, as well as you can attend our annual meeting, which will be in Winnipeg this year. But today we have a great presentation from Keshav Bhattarai. Keshav is a master's student at the University of Alberta, and he's working under the supervision of Dr. Nityananda, Khanal, and Malinda, Thilakarathna. Keshav's research is located at Beaverlodge Research Farm at Agriculture and Agri-Food Canada, Alberta. And he is evaluating the benefits of integrating perennial forages into a traditional annual crop rotation system for Western Canada. His expected outcomes will be to generate new ideas for optimizing crop productivity and profitability, improving soil health, increasing soil carbon stock, and reducing nitrogen losses to maintain sustainable farming practices in Canada. So without further ado, I'd like to send it over to Keshav.
Yeah, thank you for the nice introduction. Hello, everyone. Welcome to my presentation. The title of my research is Assessing the Long-Term Impact of Perennial Forage-Based Crop Rotation on Productivity, Profitability, and Soil Health. As we know, crop rotation has several beneficial aspects. It increases crop yield, improve soil fertility status, and break disease and pest cycle that ultimately contribute to more healthier and resilient crop. Additional benefit can be obtained with the integration of perennial forages in the rotation. With the extended growing season and ability of multiple year harvesting, it improves the nitrogen use efficiency, high root to shoot ratio, and lower biomass removal during harvesting. Increase the potentiality of carbon sequestration in the soil. Several ecological services, such as reduction in offsite pollution, conservation of soil and water, improvement of soil health, and reduction in greenhouse gas emission can be achieved with the integration of perennial forage in the rotation. The study of perennial forage seed production is very crucial in the study area, that is this region of the Western Canada, because it is the second largest forest seed producer in the world after the Oregon state of United States. However, there is a decreasing trend of grass and legume seed production in the study area. So, it can be integrated into traditional annual cropping system to optimize resource use efficiency and environmental health. I am working on ongoing research project which was initiated in 2013 at Beaverlodge Research Farm, Agriculture and Agri-Food Canada, Alberta. The first and second phase of the project were completed in 2020, and I am working on third phase of the project for my degree requirement. For the uniform comparison among the sequences, the seed yield of both annual as well as perennial crop was expressed as canola equivalent yield, which is the price ratio of non-canola crops to canola crops multiplied by yield of non-canola crops. Interestingly, the sequence second, which has creeping rate rescue, in 6 out of 8 production years have higher canola equivalent yield in comparison to the other sequences. In this way, my project will evaluate long-term impact of diversified cropping sequences. Based on the project background, the hypothesis of my research are long-term diversified cropping sequence will increase the system productivity and profitability and enhance soil and environmental health. Based on the hypothesis, the objectives of my research are to evaluate yield and economic benefit of different crops grown in rotation under various nitrogen fertility levels. The second objective of my research is to examine the soil health properties such as physical, chemical, and biological that are sensitive to change in diversified cropping system. The experiment was laid out in split plot design with 4 replicates, where 8 different cropping sequences are assigned in main plot and 3 levels of nitrogen are considered as a surfactant. The table shows the main transitioning feature of my treatment composition. As I already mentioned, as a graduate student, I am working on third phase of the project from 2022 to 2024. The example of key transitioning feature of my sequence are annual to perennials, turf grass to legume, and so on. Here is the experimental layout of my research. Here are 96 plots, and each plot size is 8 meter by 2.5 meter. Zero tillage production system was maintained throughout the different phase of the project. Here is the aerial view of my research plot in 2023. For the experimentation, other nutrients such as phosphorus, potassium, and sulfur were applied as band application during seeding for both annual as well as perennial crops. Similarly, for annual crops, nitrogen treatment was done by banding during seeding, but for the perennial crops, it was broadcasted during fall. For the weed control, pre and post emergence herbicide was used. Monitoring of disease and insect pests was done throughout the growing season. Broad spectrum herbicide will be used for the termination of perennial forage crop. Seed yield of 2022 and 2023 is the seed yield of 2022 and 2023. 2022 was the establishment year for perennial forage crops, so no seed yield was obtained for the perennial in 2022. Higher cumulative canola equivalent yield was obtained in meadow broom grass based sequence in comparison to the other sequences. And it is due to the higher seed yield and the price of meadow broom in 2022. The price of meadow broom was almost 6.5 times higher than the price of canola. The graphs show the gross revenue, which is the product of price and yield of the crop. The cumulative gross revenue of meadow broom sequence was higher than in comparison to other sequences. The soil physicochemical properties was analyzed in 2023 at 0 to 15 centimeter soil depth. Here is the table shows there was no significant difference in ball density, water content and field capacity, soil resistance, and soil pH due to the sequencing effect even after the 10 years of experimentation. While total carbon and total nitrogen was measured using dry combustion method in 2023 at 0 to 15 centimeters soil depth. Previously grown HQ-based sequences and alternative sequence of wheat and canola have shown higher total carbon and total nitrogen. Extracellular enzyme that play a very important role in carbon and nitrogen cycling in the soil was analyzed in 2023 at 0 to 15 centimeter soil depth. Previously grown HQ-based sequence have shown higher carbon and nitrogen cycling enzyme activity in comparison to other sequences. Soil active carbon or permanganate oxidizable carbon, and microbial biomass carbon was analyzed in 2023 at 0 to 15 centimeter soil depth. Previously grown fescue-based sequences have shown higher active and microbial biomass carbon in comparison to other sequences. So the major finding of my research in 2023 are higher canola equivalent yield and gross revenue recorded from meadow broom grass-based sequences were associated with higher productivity and seed plant. Improvement in total carbon and nitrogen, microbial biomass carbon, and enzyme activity were observed in previously grown fescue-based sequences. Soil physicochemical properties such as ball density, water holding at field capacity, penetration resistance, and pH did not show significant changes over the 10 years of experimentation. At last, I would like to acknowledge my research committee and funding agency, Agriculture and Agri-Food Canada. I am extremely thankful to my colleagues, Pat and Andrea, for their expertise and technical support throughout my research programs. Thank you for your time and attention.
Thank you so much, Keshav. That was a great presentation. I learned a ton about forages, and I didn't know Alberta was the second largest producer of forages, so that was very interesting. But I think we will open the floor up for questions now. So if anyone has a question, please raise your hand. Noah Burr.
I just wanted to throw a reaction. It was a great presentation. Thank you. I don't have any question to him.
Thank you.
Yes, definitely a great presentation. I think Malinda.
Yeah, Keshav, nice presentation. I have a specific question. So you mentioned that like total carbon, nitrogen, microbial biomass, it was higher following fescue. So what do you think? Like, what is the rationale behind that?
I think the main reason is due to the dense and extensive fibrous root system of keeping a fescue, as well as it also has good canopy coverage. I think that will gives good environment for the microbial activity.
Okay. Do you think like there are some like more root exudates associated with fescue compared to the others, releasing more carbon?
I think so.
Okay.
I am not fully take this thing, but I have to review some of the literature.
Yeah. All right. Thank you.
Belu.
Nice presentation. Maybe I just not catch your comparison. When you highlight the two treatment shows higher, you are not compare the two you highlighted, but you individually compare your highlight with the continuous canola as a check. Is that correct? In few of your slides, you just highlight the middle treatments. Yeah, here you compared with what? With the first column? Because your letter shows the same. That's what I observed.
Maybe I didn't understand the thing.
So you will compare this two bars you highlighted with this one, the first one?
Oh, for comparison, according to
Yeah, but yeah, you highlight these three bars. That's all labeled A. Compare with which one?
well, I'm
You compare with this one, right? In this property, you say the three highlighted one is different from this treatment, right?
Yeah.
Okay. Yeah, just wanted to be clarify. My second question is, for the short-term rotation, what's the rationale you said you change the soil bulk density?
Well, bulk density.
Yeah. What's the cause? Why you can, change the soil bulk density?
I have read some of the literature, and it is saying that this type of the physical property of soil, such as bulk density, will take longer time to change. So yeah, within this 10 year of cropping sequence, which has also didn't show any significant differences.
Okay. All right. Thanks.
I think I have a question, Keshav. Was there a reason that you chose those forage species?
These the main reason is these are the major popular forest crops grown in this prairie region.
Sorry, I couldn't really hear you there.
The main reason for choosing this forest crop is they are the popular forest crop that can grow in this region.
Okay, thank you. Okay, 1 minute left. Did anyone have any final questions for Keshav? No? Okay, well, again, thank you so much, Keshav. That was a great presentation. I know as graduate students, we do appreciate those thought-provoking questions. So thank you to everyone who asked questions as well. Actually, Bailu?
Oh no, I just clap on my hands.
Okay, sorry. So thank you so much for that presentation. Once again, our next presenter will be December 13th, Simranjit Kaur from the University of Alberta, who will be looking at mapping of stripe rust resistant genes to a NAM populations of wheat. And as well, we are looking for presenters for our 2024 series. So if you or someone you know is interested, please contact myself or Marcy and we will set you up. So thank you so much, everyone, for attending and have a great day.